So with that, I will introduce to you Beth Powell, CEO of New Pig Energy. Beth, thank you for being with us, and I'm going to stop sharing my screen and hope that that gives you an opportunity to share your screen. Okay. And I'll turn it over to you. Thank you for being with us.
Thank you. All right. Can everybody see that? Okay, good. So I'm going to talk about secondary containment regulations. I'll talk about the federal level. I'll talk about some of the API recommended practices, as well as what's going on in Pennsylvania and the differences we see between here and Oklahoma, Texas, New Mexico. And then I can cover the states of Pennsylvania, West Virginia, Ohio up here as well too. So now we'll see. Now my slides won't. There they go. Okay. So on the federal secondary containment, there are two different types of containment. Well, first of all, let me back up. Secondary is any containment that's not the primary container. So when someone's talking primary containment, that's the drum, that's the tanker, that's the bucket or the pail that the liquid is actually in, or it could even be the reserve pit. Secondary containment, it's the safeguarding method in addition to the primary containment. With the secondary containment at the federal level, they have two different definitions. It can be specific/sized, or it can be general. The specific/size, that means the containment, the secondary containment is designed to hold the entire contents of the first container or the primary container if there is a release. So if it's indoors, they want it to be, you don't have to do it for all the containers that are in the secondary containment unit, but at the federal level, it's 10% of the volume of the total containers or the volume of the single largest container, whichever is greater. And then if the containers are outdoors, say a line of frac tanks, it's the that 10% of the greater or the largest container plus freeboard for precipitation. So normally you're looking at a 24-hour rain event from the 25-year high is what you need to plan for. The rule of thumb is to add an additional 10%. So if you ever hear the 110% rule, that's that size specific container plus the 10% for rain accumulation. Now, at the federal level, there's also general containment, where you only have to plan for the most typical failure mode and the most likely quantity. This also allows passive or active systems, meaning the system is always ready or the walls rise up on their own, would be a passive system. Active system means you can rely on the fact that there are people located on site and that they would be the person responding to the spill. And I'm going to show later on the slides the BMPs for specific and size, and also BMPs for general containment. But normally under general containment, you just have to have a spill kit on site and people able to respond to the spill. They're at the federal level, they're just looking for it to not enter the waterways. So at the federal level, the regulation is the spill prevention, control, and countermeasure. With this regulation, it's only oil and oil-like and oil-water mixtures. Rule of thumb, if it coats or floats, it's considered an oil because you can have the fish kill. So milk is actually considered an oil-like mixture. For the federal level, it's only considered a reportable spill if it results in sheen on the water. Now, they did clarify that oil rigs and the frac crews that are on site should be viewed as mobile or portable facilities. The oil rigs have been doing this for years. The EPA has been focusing a lot on the completions, the fracking part of it, that they have the plants as well too. And we're starting to see more of that, especially down in Texas, Oklahoma, and New Mexico. So the oil and gas industry has an exemption at the federal level for SPCC, but I'm going to start with the section that applies to the industry first, which is 112.7C. The requirements for the oil and gas industry are that it has to be capable of holding the oil and that it does not exit that containment system before cleanup can occur. So there's a lot of options at the federal level for what the secondary containment system could look like. It could just be diking and berms, it could be weirs or booms, or it could be absorbent materials on site. Again, if you have people on site, you're allowed to use active containment measures, which means absorbents with people there to place them. So here's different examples of the allowable methods and a description of each one. And if you, at the end of this, want me to send the presentation to you, I'm happy to do that. I can give you a link where you can download it. But again, booms and weirs and curbing and dikes and drip pans and sump collections all meet the federal requirements. So there are provisions under 112.10 that you only have to meet the general requirements. So again, does not have to be sized and specific to the container. It's just the general requirements, which means you only have to plan for the most likely quantity that will happen. And then it requires the catchment basins or diversion structures. None of this is saying that the secondary containment needs to be impervious. You're allowed to have a spill to the ground without it being a reportable. It just needs to not hit a waterway at the federal level. Another federal regulation that applies to oil and gas for the secondary containment is RCRA. This one, there is a lot of exemptions for the flowback fluids at the federal level, but it does not exempt the fracturing fluids sitting on site that are unused. The rule of thumb here is it's exempt as a waste if it's come out of the ground. So if it's come out of the wellbore, it's exempt as a flowback fluid. But if it's sitting on site and has not been put down hole, and you spill it, then you will also trigger a RCRA violation because the fracturing fluids themselves are not exempt. Another federal regulation that will trigger notice of violations would be the National Pollutant Discharge Elimination System. Like SPCC, it defines the oil pollution as a sheen on water, so it has to reach a waterway. In the oil and gas, actually, most of the notice of violations are due to sediment controls, but not release of, say, the friction reducer on site. But if the friction reducer would reach a waterway, you would also pull down a violation on the NPDES as well, too. Most of the states have delegated the permitting or delegated the permits from the EPA. Now, talking about industry recommended practices, the API has two main guidance documents. They're a little different than the federal because now they're dealing more with not reaching the ground instead of reaching the waterway. Very similar recommended secondary containment practices to the federal regulations that, drip pans and retaining walls, dikes, catch basements, permanent booms, temporary booms, they're all adequate forms of secondary containment. Their guidance document is similar, still the retaining walls, the catchment basins, and you can use the absorbent. Where it gets a little different was with Pennsylvania Act 13 in 2012. This is where there's a departure from the federal requirements. With the PA Act 13, it wasn't just oil, and it wasn't just to water. It also had any of the it also included the flowback water itself and spills to ground. The other thing that it put in place was 3 additional requirements of the containment system. It had to be sufficiently impervious, it had to be chemically compatible, and it also had to have a plan that was submitted as well too. The Pennsylvania Act 13 was then codified into 78A 57. Well, actually a number of places in 78A, so I'll go through those as well too. In 57, it deals with the disposal of the production fluids. And again, it's not just oil, so it's got the brine. Here you're going to see that the Pennsylvania is a little different from the federal in the sizing requirements. For PA, it's the contents of one of the tanks in the containment. So whether it's a 1-tank containment or a 10-tank containment, we have to have some capacity to hold the entire contents of one container plus 10% for precipitation. Our rule of thumb here when we build secondary containments is once you get to 4 tanks, it doesn't matter. We can build the containment as tightly as possible to the tanks and we still meet that 110% requirement. Under 78A 64, this deals with the condensate pet tanks. This is a pickup pretty much of the SPCC. The other thing to point out with the SPCC is if you don't have 1,320 gallons on site, you don't need an SPCC plan. And Pennsylvania follows a very similar rule as to whether you're in or out. But on the fracking side, the diesel tanks are usually 10,000 gallons, so you're already in. And then I'll cover on the fracking site where you're gonna, trip the threshold. This is where Pennsylvania seems to be vastly different from a lot of other states, except for Ohio, West Virginia, and locations on Colorado. Within Pennsylvania, it's not just the frac tanks and the containers, but the well sites themselves have to be designed and constructed using secondary containment. And this includes all solid waste as well too. So in Texas, we'll do a lot of duck ponds that are like 12 by 50 in size, and they're gonna go under the pumps and the tankers. But in Pennsylvania, we're gonna do anywhere from 40,000 square feet to 120,000 square feet to put containment under the entire site that has oil-like substances and brine and flowback. So under Pennsylvania here, and we are seeing some more states follow this way, it has to be in place, this large parking lot of containment has to be in place during any phase. So whether it's drilling or casing, the whole way back to the flowback operations. We typically see 5 stages here in Pennsylvania. We'll see the air rig, we'll see the fluid rig, we'll see the flowback, and then we'll see the production, and I'm missing a stage, which I think is later in my slides, so I'm sorry, but there are 5 stages in total. The other thing that Pennsylvania put into place is a coefficient of permeability. The one argument I've had back and forth with the DEP on this is the coefficient of permeability is based on soils. It doesn't actually apply to polymer films. Its permittivity measurement is required for the polymer films, but there is a conversion factor between the two. It has to be resistant to the material, to the actual use as well too. Again, you're going to see that single largest above ground primary containment plus 10%. Pennsylvania also has requirement for a weekly inspection and maintenance of those records. So for a lot of operators, we're actually, when we're on site and we're doing a patch and repair, all of that needs to be uploaded into their record system as well too. It has to be removed as soon as possible, and it has to be chemically compatible. Now with the chemically compatible, there are a lot of chemicals on these sites. And the test method to test for each one is about $10,000. So when we were talking with the DEP in Pennsylvania, we agreed that chemically compatible meant that the liner should be capable of holding back the fluids on site for 3 days. because cleanup should occur within 3 days. So that is the test method that we test against, and it's a lot less expensive, and we can test a multitude of chemicals on the site. So the Pennsylvania DEP has a policy as well beyond the Chapter 78A. The oil and gas spill policy here, again, it's to ground, so it's very different from the federal regulations. And if it occurs in containment, it does not need to be reported unless it exceeds 42 gallons. A lot of operators here, though, however, report every spill, but it kind of goes by case basis with the operator. And then any spilled material has to be removed within 24 hours. So we typically see 4 different types of well site secondary containments. On the pad itself, which I said, can typically be between 40,000 square feet and to up to 120,000 square feet. We have some sites up here that have 20 plus wells on one location. In that case, the containment's centered off the wellheads and has a berm that's 6 to 8 inches high. On the tank containments, we're dealing with a lot more fluid in a concentrated area. So you're going to see higher berms around the tanks. That way we don't have to have such a large footprint on site to meet that 110%. Then we have leak-prone equipment such as light plants, pumps. We even have some operators that are putting the porta potties in the secondary containment. And then there's the chemical storage, which can be liquid or dry, and it has a similar berm to the pad and the equipment. They range from corrugated pipe to foam berms. So under the pad containment itself, I'm going to show some of the lessons we've learned over the years. We've installed about 120 million square feet at this point, and I've seen a lot of things. So when the industry first moved into Pennsylvania, because the Clean Streams law here, the industry received a lot of violations in the first few years because every spill to ground was reportable. So they took the liners that were used in the pits and covered the whole site with the pit liners. Worked, pretty well in dry states and in warm states. But here in the Northeast, these pit liners on the sites eventually became ice skating rinks. So they started adding a layer of felt to increase the coefficient of friction on the surface. But then we ended up with all these loose layers all over the place, and the number one injury on site for OSHA reportable was slips, trips, and falls on containment. So we kind of traded one problem for another. That's kind of where my company got involved. We decided that we could provide a laminate that would have the durability that they could rig up and rig down directly on the liner, and that it would be slip resistant even when it was wet, even when it was covered in oil-based mud. So it needed to be able to handle the equipment, rigging up and rigging down on it. It had to last through the multiple operations. We wanted to get from the air rig the whole way back to the flowback stage. And it had to be, the holes had to be readily detectable, because in the loose layered system, all they had to do was throw down a felt and cover up a hole. So here's an example of one pad that is going to go from air to fluid to completions to flowback. So this is after the top hole rig had moved off, and then here's after we're going to be adding on for the fluid rig, which requires a larger footprint. And then we're now dealing with the last one was after the fluid rig had moved off. Here's after the fluid rig moves off, and now this would be after the fracking and the equipment has moved off. The one thing that we were told by operators when we first started supplying into this is they were surprised at the amount of rainwater they were collecting, because the prior containments weren't collecting any rainwater. And if you're from Pennsylvania, there's a lot of rainwater that we're collecting when we're dealing with this. Because of the laminate structure, you're able to actually take a street sweeper and clean the surface of it. So this is how we prep the site between the operations from one to the other. Because we're putting a plastic sheet over the pad, the preparation of the pad is very important. Again, in Pennsylvania, we deal with a lot of mud, things buried in mud. So the pads that are built up here, especially in the winter, tend to be a cement dirt. And the cement, the cementing of the soil helps a lot, keeps the equipment from sinking. But the issue for the liner is they're going to come in later and drill out for the cellars. And at that point, when they do that, they're going to scatter chips all over the surface of this cement stabilized soil. So it's like scattering thousands of little knife blades all over the place. So we recommend, if the pad itself is cement stabilized, that it's capped with at least 2 inches of stone. It provides a cushioning layer and kind of a buffer between the liner and the ground that's not going to have any give to it. So of that stone, we've found that 2A modified tends to work the best. If we go into the dust realm, it just turns to mud. If we're into the riprap, it's a little too aggressive on the liner. But 2A modified, because it still has rough edges, when you roll it, locks in really well. We've also at some point tried the river rock, but because it doesn't lock in, it doesn't hurt the liner at all, but then we end up with ruts all over the pad. The stone, once it is put down, should be rolled and firm. It shouldn't be any rolling or pumping. Now we have sites that they seem to have been built over a natural spring and they're in a bowl shape, and then we're just dealing with standing water constantly. If you wanted to go one level more to protect the liner, we have operators that will put a 1B cap on top of it. So it's actually, it's a much finer stone, a little softer cushion, but it's not required. It still does need the 2 to 4 inches of 2A modified underneath it. A lot of operators here in the Northeast, because of the pad construction and the sinking of equipment, will put down rig mats. So in that case, you're dealing with like an 8-foot by 16-foot piece of fiberglass usually. So you can't be off when you're putting down the rig mats. That means the containment has to be square to start with. We square off the well heads. And then for our installs, we're marking the sides because you can overshoot and waste a lot of material without an ending line. Here as well too, we've had injuries because you're putting down a humongous piece of plastic that's going to act like a sail if the wind gets underneath it. So sandbags are very important. In fact, we sandbag each row as we move down through. If the row would take off, it has been known to carry people with it across the pad. So sandbags are very important. And then I had mentioned the starting and stopping lines for reduction of waste material. We have had a number of issues with where the felt is a separate material, and an installation company will just loose lay the liner underneath it, cover with felt. The operator doesn't know that it's never been welded together. So the seam welding, to make it watertight, it has to be welded together. And there's automated equipment to do this. You set the temperature, you set the speed. It depends on the liner and it depends on the site conditions. For our installations and the companies that we train, we have a sticker that we actually put on the welder that has all of the temperature and speed settings, depending, what they're welding and the conditions that they're welding in. The other thing with the seam welding is it needs to be spotted. You don't want to just start the welder and walk away. You're looking for if it's catching on any rocks, if it needs to be kicked out, if a patch has to be done. So when we weld, we actually have a spotter moving with the person on the welder as well too. Leak testing. Whether it's a laminate material like ours, or if it's just a a regular plastic without any friction increasing material on both sides, there are different test methods for leaks. So for our laminate liner, because we do not do a dual track weld, we do a solid track weld, then we can test with air lance and a vacuum. If there is a dual track weld, you can test it by pressurizing between the two seams. We don't recommend split weld, because now you're only dealing with, between the two tracks, maybe a ½ an inch of actual weld area. And the wedge welder that we use provides over 2 inches of overlap for the seam. If you do use the vacuum tester, it can be moved about every 10 seconds. You can do a randomized testing of it. You can test the whole seam. It depends on how critical the containment is and where it's being used. If we've had an operator that's been having severe issues with other materials in their tank containment, the first few installations, we'll back test everything for them. Patching. Whether it's a composite liner or it's a plastic liner, there's a 4-step process for patching. And with someone unsupervised in the field, it can get a little iffy sometimes on what the patches look like. If it's plastic liner, you have to dry the surface, you heat tack the edge, you have to grind the edge, and then you have to extrusion weld around the edge. For composite liners, you have to dry the surface. And in this case, because we have that texture on it, it's a needle punch polypropylene, ours requires a shop vac to dry the surface. Then we surround it with the sealant, heat tack it down, and surround it with sealant again. Kind of step through the stages. There have been different methods of attachment to the cellar. There have been operators who have had a link in the cellar that's backed up, gone onto the liner, and then spread across the site. So we don't typically loose lay the liner in unless it's a specific request from an operator. We used to attach it with ice guard. And worked really well in the summer, but in the winter, when it would freeze and submerge for a long period of time in the cellar, it would release. We've tried the metal rings. As long as they don't slip, they work pretty well. But the best option that we found is to do a spray coat of polyurea. It is expensive, but for where it's attached, if we have to cut the liner away, we will leave an apron around it, and then anybody that has to come back in and attach the liner later just attaches to that point. And for some operators, we coat the entire cellar, so it's completely leak-proof. It's a good, if someone's just putting in a corrugated versus a fabricated cellar. So we've learned a lot with berming over the years as well too. When it first started out 9 years ago, everybody was using corrugated pipe because it was very easy to get. It was very lightweight. If you're going to use it, that's fine. But if the corners aren't attached together as the containment fills up, they will just unroll. So you need to tie the pipe corners together to prevent kick out. It's also important how it's folded, because the lowest point is your sidewall. So we always bring the edge of the liner to the top of the berm to maintain some capacity. We do a lot more foam now than we do corrugated pipe, and we get it in triangular and round sizes. We do open cell and we do closed cell. The open cell collapses, but it acts as a sponge if it would be exposed to the chemicals. We use this a lot for drive-in and drive-out containments, and for containments that need to be rolled up and reused from site to site. The closed cell foam acts as a speed bump, but it is very durable. We use this around the perimeter of the large installs for drive-in, drive-out. And we use a prayer seam technique where the foam is locked in because we weld a piece of line underneath it so it can't kick forward. And then we use a stone ramp on the outside to keep it from kicking out. We also have drive-over ramps. We use these especially in the winter since the foam berm and the corrugated pipe will be driven into the mud. So we use these to maintain the berm during the winter time. They're designed to be 35 pounds. Each component weighs less than 35 pounds, so it can be installed quickly. One of the things with the secondary containment is if you have no berm, you have no secondary containment. So maintaining the berm is critical. So you don't want to park on the berm. You don't want to cut the berm away. And one of the things that's been working fairly well with one of the operators is basically they barricade around the edges of it and force people into certain entrances and exits. The most hole-prone areas are pipe racks, the backyard, and when the use of the outriggers. But the number one enemy of any secondary containment is the forks on the skid steer. We patch a lot of fork holes. For the tank containment, again, that rule of thumb for the 110% of the largest tank. One thing when you're doing the sump capacity, you have to subtract out the displacement of the tanks that are also in that containment with them. We try to segregate chemicals on site when we're doing the installation. And if you're going to do that, if you can put a berm in between them, but it's critically important that the liner from both sides extends to the top of that berm before it terminates. And we use portable containment walls that are 2 feet high. It's a good compromise. It gives us a really good sump capacity, but they can still be stepped over without having to, use crossover stairs. Once you get above 24 inches, a lot of people aren't able to step over the berm, and then it requires the crossover stairs. Fuel tank containment. If there is going to be a 6-figure cleanup on a site, it is going to be from the fuel tank. It's the diesel. The diesel will not stop penetrating the ground until it hits the water table. So if there's one location on site to be the most concerned about, it's the containment around the fuel tank. Now the fuel tanks can be single wall. In that case, they're there's the primary containment. If they're double wall, they have secondary containment built in. If they have an additional pan around them, then they have tertiary containment. And then you can also have quaternary containment. In this case, it's a double wall tank sitting on top of a containment, and underneath the rig mats is another containment. Brine tanks, you have to have permanent secondary containment. The brine tank, even though it's not intended to store oil, tends to have oil on the surface, and the federal government views these as views their capacity as being counted towards the SPCC plan. These require the crossover ladder because they're typically higher than the 2 foot. Another area where there's a lot of spills is at the transfer, and so you can install load line containment at that point. Now for the equipment on site, we got a lot of generators and light plants and sewer treaters. These containments are thrown in the half rounds and moved from site to site to site. Some of them are years old. There is a collapsible storage. We do not see this in the Northeast. It seems to be more prevalent in like Texas, Oklahoma, and New Mexico. Because they're not doing the large site containments, they're just mostly focusing on the tank containments. You can have float up walls. You can have drive-through options. For fluid dispensing, it's a high risk area, so you're going to see a lot of drip pans, quick throw berms. Under the chemical storage, here in Pennsylvania, even though they're dry chemicals, they're putting them in the containment. The DEP does ask that they are segregated. It's not in the regulations, but it's highly recommended to segregate the chemicals. If there's going to be a lot of driving between the chemicals and the main pad, sometimes I'll recommend that there's a driveway and that you do not cover it with liner between the two. But again, the DEP has asked us specifically to compartmentalize the flammables from the incompatible materials. Not a regulation, not a requirement, but a request. So let me see if there's any questions. Let me know. Let me escape out of the PowerPoint.
Beth, as you do that, I had a couple people email me questions. So if you can hear me okay, I'll ask you a question or two.
Okay.
And please, folks, if you have a question, go ahead and get in the chat or the Q&A pod and ask the question. So how do you'd mentioned that we accumulate, particularly in the Northeast here, a lot of rainwater on pads. How do we handle the rainwater on those pads?
They'll call a vac truck to site and they'll suck the water out. And in a lot of cases, that water is going to go into the water they're collecting for the fracking operation. So they're not trying to send it to the wastewater disposal well. It's not going there. It's usually stored in their impoundments or in their water tanks to be used during the fracking step.
Okay, thank you. A question from Craig here. Are there specific rules for containment, such as a tank battery site in a floodplain area?
It's going to be up to the operator. You have to, for the SPCC plan, you have to state what you're going to be doing to prevent it from hitting the waterway. So when you do the plan, you're going to have the topographic of the area. You're going to have to show, the direction of flow, and usually the 110% tank capacity. There doesn't tend to be any additional requirements for the SPCC plan, but your permits to be able to put the tank battery there may require a different level.
Okay, thank you. Beth, are you hearing from customers regarding budget cuts, and do you see any change due to the energy environment?
Oh, yes. Every week,
Yeah.
they're asking for 20%, and then a few weeks later, another 20%. So yes, the industry's really, really tight right now. It's going to be interesting what we're seeing with the shut-ins in Texas, because we opened a branch there this year. Great timing. They're shutting in. We think it may cause a little bit of resurgence up here in the Northeast, because the Permian wells were generating basically waste gas that they were, asking people to take away. So that was, I guess, depressing the price up here in the Northeast. But now with the well shutting down there, it may actually help with pricing for gas up here, since it's not a byproduct anymore from the shut-in wells.
Okay. And a question out of the Q&A pod, Beth. Are there any requirements for wildlife exclusion? And if so, how is this handled?
We haven't seen any requirements for wildlife exclusion. We have interacted with the wildlife. Those high wall containments can get bees nests underneath the edges of the liner. We've had to deal with that. Snakes seem to like laying on warm liner, so we run into a lot of snakes, and we run into a lot of dead frogs in the cellars. But other than that, there hasn't been a wildlife impact for our portion of the permits.
Okay, great. So I think you've answered the questions, and just as we, Beth, I'll give folks, another chance if they have some lingering question to place in the Q&A pod there. And as we do that, I'd ask Dana if she might put up the poll questions. We would love to receive feedback from you all that attended today, and appreciate your attendance being with us, but we also appreciate the feedback and understanding how we do and what we might do next time as well. So with that, if you just take a moment, there's just a couple questions here. If you'd all take a moment and just answer those, we really would appreciate it. And besides that, as I'm looking at some of your notes here, some of you have made us really envious with the temperature range you've seen, and then a few of you have made us feel really good about the temperature ranges we're seeing here in Pennsylvania today. So thank you for that. There is a question that came that came in, and that was a question about providing the presentation slides to follow up. And Beth, I think you'd mentioned the availability of them as well from yourself, and
if you want to share them, John, that's fine. You have the copy I sent you too.
Okay, thank you for that. And if you want to go ahead and catch it and catch those particular parts of the presentation that you'd like to see again in the recorded version, it'll be up there, and you'll be able to catch them there as well if that's easier for you. Sometimes as you all know, sending some big presentations through email gets clogged up somewhere. And with that, so Bruno, thank you for telling us how nice it is in Southern Florida. Beth, there is another question. What percentage of flowback fluid needs to be treated off-site at a specialized facility like the Eureka Resources facility? That's very specific and esoteric, probably just to a very small area.
Yeah, and I don't deal with the flowback. I just, put the containment around it. So I'm not familiar with the movement of it. I know that Pennsylvania, we recycle a very high percentage compared to the other states, but I'm not the person to be able to answer that question.
Okay, thank you. You know what, I'm going to attempt to do this one last time, Beth. First of all, thank you, Beth, for participating, being our presenter today, providing the excellent information. It's been great, and we thank you for taking the time to do that from your schedule. And that last question may just lead into next week. So our next webinar will be next Tuesday, April 28th, again at 1:30 Eastern Time. And Dave Yoxheimer, who many of you know, will be our presenter, and that sounds like that last question may be one that he would be very glad to handle perhaps next week. So with that, I don't know if we have anything else but to thank you again, Beth, for your presentation. We certainly appreciate your time and energy to put on a presentation and of such in-depth knowledge. With that, folks, thank you again for joining us today. And we'd look forward to seeing you perhaps next Tuesday afternoon as Dave Yoxheimer joins us. So with that, I'll grant you adieu and thank you again, and have a great afternoon. Thank you, folks.
Thank you.